everyone, welcome to your section 3.2 notes. This is where we are going to be looking at the specific angle relationships that we discussed in section 3.1 when our transversal actually intersects through parallel lines. In section 3.1 we talked about transversals just intersecting any line. So if you really quickly remember, we had just two lines, transversal going through. Do you remember the name that we called angles 1 and 2? Hopefully you said corresponding. What about angle 1 and angle 2 here? Do you remember what those were called? Alternate interior. And then if I put 1 up here and 2 down here, then the relationship would be named alternate exterior. And the last one we had, if they're in 1 and 2's there, we called those consecutive interior angles. Good. So now what happens when we make those parallel lines? So our corresponding angles postulate tells us the following. If parallel lines, then corresponding angles are congruent. So if parallel lines and corresponding angles are congruent. So in this diagram here, I want you to input angle 1 and angle 5. And because I have parallel lines, and we do have something, okay, stop doing that. I do have something new here that I want to bring forth to you guys. We haven't touched upon this yet. Whenever you see little triangles on lines like this, that means that we have parallel lines. So this is our symbols, because remember geometry is all about symbols. These are our symbols for parallel lines. And there's actually an abbreviated symbol for parallel lines. Instead of just writing out parallel lines, if you just want to physically make like an 11, that's our symbol for parallel lines. It's just shorthand, saves you some time. So corresponding angles, remember top left, top left. And we're always picking from this group of 4 and this group of 4 down here. So top left, top left. So if my lines are parallel, what ends up happening is my corresponding angles are going to be congruent. So in this case, angle 1 would be congruent to angle 5. Okay, let's move on to the next one. Alternate interior angles. If we have parallel lines again, so again, remember the arrows are there, then alternate interior angles are congruent. And here I have angle 4 and angle 5, so angle 4 would be congruent to angle 5. Alternate exterior angles. If parallel lines, then alternate exterior angles are going to be congruent. And plus you can kind of use your common sense, right? Look up there at angle 1. Do you see how that looks like it is an obtuse angle? And angle 8 looks like an obtuse angle. So those would be congruent. So angle 1 would be congruent to angle 8. Again, notice our triangles on the lines. That means parallel lines. And the only ones that are not going to be congruent are your consecutive interior. And your consecutive interior angles are going to be supplementary. So if parallel lines, then consecutive interior angles are supplementary is what we have here. So 4 and 6 would not be congruent. And use your common sense. Look at angle 4. Doesn't that look like it's an obtuse angle? And doesn't angle 6 look like it's less than 90, so acute? So there's no way that they would be equal to each other. So in this case, the measure of angle 4 plus the measure of angle 6 would be equal to 180 degrees. Because remember, supplementary means they add up to 180 degrees. Okay, so let's put this into practice. Here we go. First problem, I'm given parallel lines. I know that they're parallel lines because I have the little triangles or the little arrows on my lines here and here. So that tells me I have parallel lines. So now let's try to find the measure of angle 1 and the measure of angle 2. So notice 1 would be the same as this angle here, but I don't know that angle there. 1 would also be the same as this angle over here because of your alternate exterior, but I don't know that angle there. So I'm going to have to do a little bit of thinking. 1 is also the same as 50 because aren't they vertical angles? Yeah. So the measure of angle 1 is going to be equal to 50 degrees because those were vertical angles. Now let's focus on angle 2. What's true about angle 2 and angle 50? Well, they're consecutive interior, which means that they should add up to 180 degrees. So 50 plus the measure of angle 2 should add up to 180 degrees. So subtracting 180 minus 50 tells me that angle 2 would be 130 degrees. And it's always good to put that little degree sign there so we know we're talking about the angle measure. All right, moving on to the next one. Ooh, this one looks a little bit more complicated. We need to find x and y. Okay, so let's first focus on x. Zoom this in a little bigger. Okay, so where do I have my parallel lines? Well, right here I have a triangle on that line and right here. So the yellow lines are the lines that are parallel, right? Now I'm going to focus on this being my transversal. And because I can, let's ignore all of this unnecessary stuff. And we'll come back to that here in a second. Okay, so ignoring that, do you see what x is going to be equal to? Well, these are corresponding angles, which means that they are going to be congruent when my lines are parallel, right? Because we have little triangles there. So x is going to be equal to 70. So if I get rid of all that other noise, it simplifies it a little bit, right? Okay, so now let's bring all that little noise back. Okay, so now we have our x equals 70. So now let's focus on finding our y. So I'm going to put a little 70 degrees in here. Now let's focus right here. Ignore all of the rest of the stuff. So let me scribble it out. Get rid of all this, and all this. Okay, so notice we have 3 angles that make up a straight line. And how many degrees should it be all the way around? Well, it's half a circle, so it would be 180 degrees, right? So 70 plus that 50 plus your y should add up to 180 degrees. Well, 70 plus 50 is 120. 120 plus what is 180? Well, y would be equal to, 60, not 50, 60, right? So we would subtract 180 minus 120. So we get y is equal to 60. Alrighty. So we solved for both the x and the y. The diagram looked complicated to start out with, but if you can get rid of some of the things, it makes it a little bit easier. Okay, so here we have our next example where we're going to add some algebra into the mix. And we're actually going to make your life a lot easier, and you guys are just going to have to solve for x and not need to state the theorem y. So you can get rid of the part that says and state the theorem y. Okay. All I care about is that you guys can actually figure out how to solve for x. Okay, so here we have parallel lines. Notice my triangles on my lines. And we have 2 equations. I've got, or not 2 equations, 2 angles. I have an angle of 70 degrees here. Notice that that angle is on the exterior, and my other exterior angles would be down here. Do I have any angles occurring down here? No, I do not. And if we think about all of our different types of angles, I have alternate interior, I have alternate exterior, consecutive interior, and out of those 3, only one of them says exterior, and that's alternate exterior. So because I have 1 exterior and not 2 exteriors, it can't be an alternate exterior. It can't be an alternate interior because 70 is not in the interior. It can't be a consecutive interior because 70 is not in the interior. So that kind of leaves me with just one option, which is corresponding. Why is it corresponding? Well, this is in the top left. This is in the top left. If we think about our group of 4 angles, right? Okay, so because I have parallel lines, what's true about corresponding angles? Remember we said corresponding angles are congruent in our boxes when we were filling in our boxes. So because they're congruent, that means they are the same. So I'm going to set 70 equal to 3x minus 14. Can we solve that equation? I hope so. Using the addition property, add 14 to both sides, gets us 84 is equal to 3x. Using the division property, 84 divided by 3 gets me 28 is equal to x. I solved for x. Now I am done. Okay. All right, so the next one, again, we're not going to worry about stating the theorem why. I just want you to be able to solve for x. So you can cross that part of the directions out. So let's get rid of that. Oops, I almost took out the x. All right, so now let's look at what they give us. Here I have an angle 75. Does everybody see how that's in the interior of my parallel lines? So what are my options for interior? Well, we have alternate interior, we have consecutive interior. Those both have the word interior in. Let's look at the other angle. Is that one also in the interior? Yes, it is. So that means it has to be either alternate interior or consecutive interior. Remember, corresponding is when one's in the exterior and one's in the interior. They're not going to be both in the interior or both in the exterior. So I have interior, interior. Are they on the same side or are they on the different side? Are they alternating? Well, these are both on the right-hand side of that transversal. Remember, the transversal is this line right here. So that means they are consecutive interior angles. And what did we say about consecutive interior angles? They are supplementary when our lines are parallel. And what's true about supplementary angles? They add up to 180. So my equation is going to be those two angles added to 180 degrees. So my equation is going to be 75 plus, don't worry about putting those parentheses in there. That's just grouping the whole expression together with for the degree sign. So just get rid of it when you write it in. Let's do a simplify. 75 minus 10 is 65 plus 5x equals 180. 180 divided by 65, or minus 65, sorry, using the subtraction property, gets me 115. Division property, dividing by 5, gets us x is equal to 23. And I am done. Okay, so we've got corresponding, we've got consecutive interior. If this problem would have been a bit different, like for example, if it would have looked like this instead. So here are my parallel lines, and we had a 75 here, and we had, I don't even remember what it was, 5x minus 10 down here. Notice how they're both angles are in the exterior, which makes them alternate exterior angles. So that would be congruent to that. So I would set 75 equal to 5x minus 10. If I would move that 5x minus 10 to, let's say, right here, now I have corresponding angles. I would still set those equal to each other. Or if I move that 75 to right here, now I have alternate interior angles, and I would still set them equal to each other. Okay? So, kind of use common sense. If they look like they're going to be equal angles, set them equal. If they don't look like they're going to be equal, like one's obtuse and one looks like it's acute, then you probably are going to add them up and set them equal to 180 degrees. Okay, so that concludes your notes. Move on to your next task. Bye.